Now let's take a look at the next set of test specs in RPN calculator. Fails informatively when there's not enough values stashed away. Now this is designed to be a very light introduction to error handling in JavaScript. This is not going to be a focus in Foundations. This is probably the only exposure you'll have to it. But it's great to have some type of introduction and idea upon what it is. So there's a hint above. The following test spec tests if a custom exception is thrown. This will help a user know what is wrong with their calculator when their calculator is empty or not full enough to actually run an arithmetic method. So when we run plus, when we call minus, when we call times, divide, all those methods require the stack to have at least 2 values inside of it because we're popping 2 values off the stack every single time. So if there is 1 value in the stack, well, whenever we get to the expression that needs to be evaluated, in this scenario in the divide method, when we do num2 divided by num1, if we only had 1 number, we're going to get some type of error there, or just not a value that we expect, probably not a number. And if we didn't have any values, well, you can see the problem that we have there. So what we want to do is create an exception for our user to see when we try running one of these functions, when the stack is either empty or not full enough to perform the operation. And there's a hint here to review the throw statement. So if we command click, we can take a look at that. And also, before we even look into this documentation about the throw statement, let's take a look at the error that we're getting in Jasmine. So expected function, so whatever function was invoked, to throw an exception. And in our test case, we expected this plus function, or it's really a method, so we expected this plus method to throw an exception. And it's not in this instance. So inside of this test case, here we call rpn-calculator.plus. And remember, with all of our test cases, inside of the before each function, we're always assigning a brand new instance to that variable. So when we get to these test specs, does our stack have any values inside of it? Well, the answer to that is no, it doesn't. When we create a brand new instance, the stack is empty. So this is why this error should be thrown when the stack is empty or there's not enough values in there to perform one of these arithmetic operations. Jasmine uses this to-throw matcher, and if we look at the documentation for that, which I have pulled up right here, to throw, expect a function to throw something. So throw is a function in JavaScript. We can see it right here. It creates a statement, and if we look at some of its documentation, we use throw followed by an expression. And if we look at more of its examples here, notice we can have throw followed by a string or throw followed by a number. And if we were to throw these in our browser, let's say throw error2, notice it says uncaught error2. And we're not going to get into what uncaught means, but this is a way to tell your user that we hit error 2 and you should look that up, or you should do something about that error. We're going to be a bit more descriptive to our user because we're expecting our user to not have a table to look up what error 2 is. Instead, we're just going to return a string that describes the problem. And let's take a look at that string. The string here says RPN instance is empty. So this is slightly generalized because we should also throw this error if there's only 1 value inside of the stack. But let's see how we can actually use this throw statement. So inside of our plus function, here we're going to pop 2 values off the stack. But as we know, with this RPN calculator instance inside of these test specs, there's nothing inside of our stack to pop off. So what will happen here? Well, if we actually execute the plus function, we would be doing something like this, undefined plus undefined. And when this evaluates, what value is returned? NaN, which stands for not a number. And this would be a weird number for your user to get back if they're using your calculator. So instead of even evaluating all that code, let's give them a warning when they try to run the add method. So in our text editor, all we have to do here is say something like if this dot stack is, let's say, less than, this dot stack dot length, because we're seeing the length of the array. If it is less than 2, we want to throw an exception. And the exception we're going to throw is this string right here. And I'm going to copy and paste this string and put it in the if statement. Now, if the stacked length is less than 2, we're going to throw this exception. And in addition to that, the throw statement will stop the rest of the execution of our code, so nothing else will run. So if I save this code, we're still failing some of our test specs because we have to do this for every single arithmetic method that we have. But notice, we're only failing, here's one that we're failing, here's the second one that we're failing, the second expected statement, and the third expect statement. The rest of the statements are the rest of the test specs are unrelated. We're only failing 3 of these though, and we have 4 arithmetic methods. So that's an indicator that we're passing for our plus function. To also further test that theory, what we can do here is just comment out the other expect statements inside of this test spec and just see the one execute with the plus method. So I'll save that, and we go back into the browser here. Notice that we're now passing because we're only running the expect function for the plus method. That's testing the plus method. Now, I mentioned before that when this throw method is invoked and thrown and that exception is raised, the rest of the code in this function doesn't execute. So it's kind of like a return statement in that sense. And let's test that for a moment. So I'm going to create a function here called testing throw. And inside of this function, let's console.log executing. Then we'll throw except statement thrown. And last but not least, we'll make a last console log after exception. Okay, so here I'll save this, and now I'll say testing throw. And when I run this code, we want to see, and this is the behavior we expect to happen. For the first console log runs, executing. Then we should see this except statement thrown, an exception is thrown. And then this last console.log statement should not execute at all. Because once this throw statement raises an exception or throws an exception, we're going to stop the execution of this function right at that line. So when we run this code, that's exactly what happens. Notice testing throw is executed, then the executing string is logged to the console, and then the exception is thrown, except statement thrown, and then after exception is not logged to the console. So all we have to do now is add this if statement into the rest of our functions. So we're going to copy and paste here. I don't love this idea of copying and pasting everything because a lot of our functions have the same exact operations, right? We're popping values off the stack. Now we're also going to be adding this throw statement here, this if statement to eventually run our throw statement. There's some duplication here. And one of the best practices, or a practice to follow in programming, is drive, which stands for do not repeat yourself. And we're definitely repeating ourselves here a few times. So get ready for it. We are going to refactor some of this code in a moment. But for now, let's just see if our functions currently execute. So notice where I placed all of these, the if statement inside of each arithmetic method. I placed it at the very top because we want to test whether the stack length is less than 2 before we actually start running any of the code inside of this function. If it's less than 2, we want to throw this exception immediately. Because if we actually start running some of this code, and let's say we push some type of value into the stack, well, we might have a funky value then in our stack that we might use, and then it's going to kind of pollute our stack if we have, let's say, the value not a number in there or undefined. So we don't want any of this code to run, so we're going to put this if statement at the start of all of these arithmetic methods. So now when I save this code, and don't forget if you were following this video and you commented out some of these other test specs when we were just testing the plus method, comment these back in. And now when we run all of these specs, notice we're passing them. Let me just go to my spec list so we can see it. Fails informatively when there's not enough value stashed away. So we're passing this spec. Great job. Now, if this was a little confusing to you, really don't sweat this too much. This was just an introduction to error handling in JavaScript. In the rest of Foundations, we're really not going to look at error handling too much more. This was a light introduction just to have some exposure to it in case you come across it in some documentation or maybe a tutorial you're doing on your own online. This won't be on any type of checkpoint or anything like that, and we'll cover error handling a lot more in depth in the immersive portion in week 1.